Good morning, everyone. We're just gonna give everybody 15 seconds, 30 seconds to join the call. Yeah, and we will slowly get started. Thank you very much for joining the webinar we're hosting today. NTI is the host, together with Real-Time LCA, the technology that's also being explored in this webinar. Ramboll is our engineering partner, or the engineering partner for the client, Region Syddanmark. And what we'll be going through is how, for this specific project, they reached DGNB Gold, and using digitalization and building LCA in the process to get there. It's going to be 1 hour. It's in English. We have more than 10 countries participating across Europe. There will be QA throughout the presentation, so feel free to ask any questions throughout, and we'll try to answer them throughout. The recording will be shared with all registrants afterwards, and if you are interested in the presentation, then we will also share that. We will ultimately also send you a short survey, and we really hope you can give us some feedback so we can improve from time to time. My name is Nabil. I am the Business Unit Director for Real-Time LCA in the NTI. Together with me today, I have Frederik Escofron, who's a very competent sustainability consultant with Ramboll, and also DGNB consultant and auditor. Over the next 60 minutes, I will spend some minutes setting the team, talking to regulation and the increasing importance of LCA. We're focused very much on a specific project, harvesting the learnings from that and sharing with the rest of you. Frederik will open with sharing details about the project in question, how he's approached it in a connected digital team, the results, the outcomes, how do they improve the sustainability dimensions of the building, and ultimately I'll be giving you a world premiere on how you can work with and talk to your sustainability data through the chat agent that you are using today. And why is this session important? And why now? We are experiencing a paradigm shift in how you are building buildings today. We see the European landscape cross the threshold. Building LCA has been voluntary ambition in regards to certification, primarily, and now to a regulated practice. In Denmark specifically, we've seen regulation become some of the progressive legislation worldwide in reducing the climate impact of the construction industry. But going across all of Europe, we're seeing the whole European area. In France, we saw the first legislation in 2022. In Denmark in 2023, Iceland recently in September 2024. And we're seeing this movement across all of Europe, more or less, with some countries being first movers. France was pioneers. Denmark has the most progressive legislation worldwide, and Germany and Italy has introduced it for public buildings. And that's more or less the movement that we're seeing across Europe. But if you are an EU member state, then we've already seen legislation trying to curb the emission of new buildings. We have the EU taxonomy, which was required disclosure for new buildings of 5,000 square meters. We have the EPBD, which is maybe will have the most impact across EU member countries. The EPBD is the European Performance and Building Directive, which from the 1st of January 2028 will require life cycle global warming potential on energy performance certificates. This means that you will be required to do a whole building LCA on anything you're building from the 1st of January 2028. And on the 1st of January 2030, all EU member countries must have actual limit values, which in practice means you would have a CO2 budget in parallel with your financial budget, and you need to manage both the consequences for spending more money is maybe a worse business case. You need to find that those resources. If you have increased your CO2 budget, we don't really know what the consequences are, but fines are expected. So over the coming years, we're gonna see whole building LCA in some areas being voluntary, in all areas in EU being mandatory. In addition to regulation, what has been shaping whole building LCA over the last couple of decades is the proliferation of certification, building certification, sustainable building certification. We're seeing mainly three international schemes: DGNB, which is dominant in Denmark, and the project specifically gone through in this case. Internationally, we have BREEAM, we have LEED, and in addition, you have several local certification schemes. So going forward, you would still be needing to do a whole building LCA to get the relevant points in the certification schemes, but you would also have to adhere to the regulation that is enforced in some countries and soon enforced in all European countries. Continuing working with whole building LCA in an often manual way will still require you days and weeks, where technology actually can reduce that to hours. You would have less time to do more variation. You spend more time gathering the documentation from different sources and having a shared thread across can be difficult. So, as summarized here, the regulation does not get easier. It's only being significantly harder. So the tooling around it has to improve. In addition to what you will see being demonstrated in this case today, which started with 2023, we've also naturally adopted and explored how artificial intelligence can help our users better understand, reduce, and document the climate impact of their buildings. So if you hang around to the end of this presentation, we'll also be doing actually the world premiere on how you can integrate Real-Time LCA very easily with the chat of your choice. In this case, I will be demoing it together with Claude. Very interesting productive way to start talking to your whole building is. So I'm looking forward to share that in the end. And now we're going to go into the specific case. I've set the scene. I'm going to give the word over to Ramboll and Frederick and let him tell a little bit more about the project that we'll be going through here.
Thanks, Nabil. Just a second. Yes. So hi everyone, my name is Frederick, as Nabil mentioned, and I'm going to take you through some of the most important learnings that we've experienced from this project. First of all, just a short introduction of who am I. So I work at Ramboll. I'm a sustainability manager in the sustainability consultancy department. I'm a certified DGNB auditor, and I'm also a DGNB buildings and use consultant. I also do a lot of LCA and work as a LCA manager on different kinds of projects. And my experience ranges from housing, office, healthcare, and logistics buildings, and of course also this healthcare project. And I've been with this project from the initial bid phase to the certification, which is not finalized yet, but we'll cover that soon later in the presentation. Just to set a bit of context for this presentation and what are we building in this case. So this is a new blood and plasma donation center located in the middle of Denmark in Kolding. It's about 1,000 square meters with a budget of 55 million. It was done as a design build contract, and I'll get into the team on the next slide. The funds were approved for the client in 2022, with construction starting in March last year, and hopefully will be opening next month. And the purpose of this project is to strengthen Denmark's self-sufficiency in life-critical medicines. And an important thing to notice here is that the donation is voluntary, and therefore we need high standards to ensure a good experience for the donors. So just a bit about the team here.
I think you like screen, Fred.
Oh. Is it working now?
Yes.
Okay, everything's good. So this was just the slide that I was covering. As you can see, where the building is located in Denmark. And then moving on to the team of stakeholders, I'll just cover this briefly. The client was the region of Southern Denmark. As Nabil also mentioned, the architect and landscape architect was Kräver Architecture. The contractor, which had the design build contract, was Egil Rasmussen. And we, as Ramboll, have the disciplines of structural engineering, HVAC, electrical, CTS. And of course, also we were a sustainability advisor on the project, where I maintained that role primarily. And then jumping into the sustainability ambition of the project. From the client side, it was a minimum requirement of DGNB Gold according to the 2023 manual. They had also defined some minimum requirements inside of the DGNB system that we needed to fulfill. On top of the client's minimum requirements, we together as the project team defined some additional sustainability targets in order to achieve the DGNB Gold ambition. So some of the key highlights here, which I will also be covering later in the presentation was we set a high ambition for hazardous substances in the project under the criteria of environment 1.2 in DGNB. We work with certified timber. Most of the exterior construction is a wood-based construction. We also worked a lot with indoor air quality, the daylight, and most of all, we set a target on the LCA of 10 kilos per square meter per year. At that point, the requirements from the Danish building regulations was 12 kilos, but because this project was below 1,000 square meters, there wasn't any legal threshold applied to the project, but we decided to set the ambition of the 10 kilos in order to achieve the DGNB goal. And of course, the full sustainability program covers all of the DGNB criteria. So these are some key highlights. And then a bit about the digital chain in the project, which was together with sustainability, also a high requirement from the client. It was mandatory, and they provided us with high ICT requirements from the beginning. We, as Ramboll, are continuously working with active BIM across all disciplines and use a lot of tools to support the modeling. In this case, we, of course, used Revit for model offering and coordination across all disciplines. We also used the tool ACC provided from Autodesk for internal clash detection and also collaboration between the internal disciplines. On the cross-discipline scale for clash detection, we used Solibri across the project and multiple times as well. And then the main thing relating to this webinar was that we had the Revit models connected to Real-Time LCA so that we could do continuous LCA as the design evolved. Another digital tool that we used was OpenFrame, which is a digital platform for doing the DGNB certification. This was client provided, so the client provided us with this platform, and so that we could use it to ensure the DGNB documentation. It made we had one place for all of the DGNB documentation, and it replaced this spreadsheet that you usually use on DGNB projects, but also replaced communication by email and also the file structures that we usually work with. So this platform contained all of those. In the platform, we had everything from requirements, also the evidence for the score, and at all points, the full team could look into the platform and have visibility of what was being done, and also, of course, a live DGNB score of the project, and you could follow all of the criteria, and also made us ready for third-party verification without any data export. Then, of course, we also worked with Real-Time LCA, which was also a tool provided by the client. We had the live link between the Revit model and the LCA calculation, and we updated this a lot of times throughout the process. So we had a continuous calculation as the design was developed and also specified. We evaluated the new materials on an ongoing basis, but of course focused on some of the main emission drivers. I will cover this a bit more later. So whenever there was a new product added to or a new material added to the project, we would ensure that it fulfilled the LCA criteria that we had. At some points, we used manual input where precise figures weren't available, where we could use some of the quantities on site, as this is, of course, more detailed than anything we could have in the model. We also used Real-Time LCA for the transport account A4 as part of the LCA documentation for for DGNB. And one main thing here is that LCA is an ongoing process. It's not a one-off report at the end, mainly because we had this goal of 10 kilos, which, as you can see on the image, is around 8.2 kilos for now. And then I will cover some of the results and concrete outcomes of this project. The main thing, which is also very important to talk about here, is that we went from about 11 kilos as a starting point in the initial tender phase to an expected at handover 8.2 kilos of CO2. So we started above the 10 kilos target for the DGNB Gold. What we did was that we did some initial calculation at first. These were primarily based on generic data according to the Danish building regulations. We decided to use some product-specific EPDs where possible and where the contractor was sure on which material to select. In the early phase of the project, before handing over the tender, we identified about 20 targeted measures to go below the 10 kilo ambition. Not all were necessary to reach the target, but just to list up all initiatives so the contractor has the ability to choose what they wanted to go with. We had some focus areas in this case, which was the structural steel. We also worked a lot with the insulation and concrete in the project. We did a lot of variant studies comparing alternative materials and also analyzed a lot of product-specific EPDs. Some of the key highlights is that we used CO2-reduced steel. That gave us a 30% reduction for the structural elements. We also used low carbon variants in foundations and ground slabs. And the EPS insulation was a version with recycled content. So those were some of the main drivers of reducing the target. Also, a lot of further reductions came from design refinement and a positive market trend. We also had a unexpected significant gain from EPDs on solar panels, which was not a project requirement, which was it was a bonus. And we're expecting a result now for 8.2 kilos. Another thing we worked a lot with was the hazardous substances from DGNB. We had a big focus on products containing chemicals. So we work with indoor climate labeling, VOC limits, and different environmental certifications. We had an ambition of 90 points. That's a very high ambition level, and it covers all trades. And it covers different kinds of materials like sealants, paint, adhesives. We identified some product groups that we needed to have a bit more focus on, but that worked out quite well. I'll cover that in the next slide. And we also see that the market is improving a lot. A lot of the suppliers are getting better at documenting all of the hazardous substances besides the EPDs. The requirement for hazardous substances required us to work a lot with material control in the project. So the process here was that we at first embedded the requirements in a dedicated specification alongside all of the other DGNB requirements that we had. We did a pre-construction approval before any of the subcontractors started on site. And then we had ongoing site checks, both from a sustainability manager perspective, but also from the construction manager. We had a hard time with this. It is taking up a lot of time. And in practice, a lot of requirements get lost when contracts are being made. A lot of products are substituted, which we need to control multiple material groups a lot of times. Perhaps stock runs out and they need at the last moment to substitute some product. And if we had any failure in this, we could have a non-compliant product in the building and of course has our DGNB score at risk. Our solution for this was to have a master material register where all of the materials used in the product were added pre-construction. This contained the product, the location, the status of the compliance, and also which documentation was available, and also later in the project formed the basis for the final DGNB documentation on hazardous substances. Another thing was the indoor climate. We in the DGNB score had a strong score across all 4 indoor environment criteria. We worked with the daylight in the building. We set stricter targets and achieved a quite high score. You can see the image on the right, which is from the daylight simulation. We also worked a lot with thermal comfort. We set high standards to ensure a good experience for both staff and donors. We also ensured future-proofing with the thermal comfort against projected climate data. We also worked a lot with the acoustic quality. We set stricter targets and also expanded scope beyond the building regulations. And also, of course, the air quality with the low emission products regarding the hazardous substances and also high ventilation standards. And all of this is important to enhance the user experience, to ensure retention of voluntary donors. It's very important for the client that the donors has a great experience and wants to come back. And for now, we are currently in the process of achieving DGNB Gold. We received the pre-certification in December 2024 with a great buffer to the DGNB Gold, the necessary DGNB Gold score, and currently in the process of collecting the final documentation from the site. We expect the final certification before the end of 2026, and the first donors are expected in a couple of weeks here in the middle of May. So that's where the project stands for now. Some of the key learnings of the project. One of the things is that the market is ready if you ask the right questions. It's important that you know the market, but if we define the requirements clearly, in this case for the hazardous substances, also certified wood, and also CO2 requirements at material level, we're actually able to get more than we ask. We need to embed them in contracts from day one. What isn't specified isn't delivered, and it's also hard for the subcontractor to ensure this. So we also need to follow them along and ensure that they have understood the criteria. A lot of compliant products exist, but it's not always what's offered first. So we need to follow up and have a dialogue and also ensure the time for the subcontractor to substitute the products. The main challenge here is that we need to maintain the control from initial contract to the site handover and the part that is in between those two. It requires a lot of time and resources from the project team to ensure this. Another thing is that LCA is a decision tool. It's not a final report. In this case, we saw that the early development is key. It's much easier to change in design than in construction. So the thing we did here was, of course, the 20 initial measures to improve the LCA on the project. That was very important to achieve the score we did. Also, that we start out early. The data foundation needs to be in place when decisions are made. We need to have, for example, in this case, analyze the different materials so that we can make a decision based on it. And the drop from 11 to 8.2 in this case happened throughout the project. We had some ongoing in the project, also here at the final delivery, and of course from the beginning where we decided on the project. And the main thing to notice is, of course, the LCA is a live tool. It's not a compliance report, so we need to work with it throughout the project. And then we have another learning with the work with connecting the BIM models to the LCA tool is that the digital chain only works if the level of detail is defined from day one. In this case, we had a highly detailed requirement from the client, but we need to ensure that these are executed and not just defined. So in the initial tender phase, the first LCA calculations were manual. We couldn't use any automation at all because the model wasn't mature enough. Sooner in the project, of course, this was connected when the detail levels was better. Some of the common issues that we saw where we needed to ensure quality assurance on the LCA calculation was duplicate materials, missing elements, and inconsistent modeling, which required a lot of time and resources from our side. So in practice, we used a model-driven approach where possible and manual where it was not possible, and also used some of the quantities from site to ensure the best data foundation for a calculation. So my recommendation would be to plan for a hybrid approach from the start, as that's probably more reasonable, and as the model gets better, you would have more detailing and can you ensure better calculation or more detailed calculation. Yes. So that's about it for now from our side, and you're welcome to ask any questions in the Q&A section at the end.
Thank you very much, Frederick. Please feel free to stop sharing slides. And I would just want to say that, yeah, thank you very much, Frederick. So the talent and the competence with the engineering firms, with the architects to understand, reduce, and document emission is there, and that is also increasing. We also see real estate owners and developers, in this case, Region Syddanmark, having a high standard for sustainability with DGNB Gold, and in addition, also a high standard for how to work with digital tools. It's no secret that in 2023, our platform, Real-Time LCA, was still new, but they were committing to working in a more digitized way because they saw the direction things were going. And in this new era of AI, we're truly experiencing a transformational shift in how we do work. And we naturally also need to apply this to the whole building LCA. So I promised you a world premiere, and I will start sharing that with you now. Yes, do like this. I'll start sharing, and then I'll take you here. So this is Real-Time LCA for some of you that hasn't seen it. In this specific case, we in a customer organization called Square Meter, who have allowed us to share some insights on their project. Square Meter is a Danish-based developer, and currently in the process of developing a 80,000 square meter lot. In that regard, they wanted to explore different design options and what is the climate impact of those. So these massing models were done in Rhino. So we are in the zoning phase, very early stage design. And one of the tasks that they were looking at was, depending on how the massing of the building is, how does the climate impact look? In this case, we can press and compare two different projects to each other and see how they're emitting different detailed data, and also some analytics on the comparison of the two projects. You can dive into a specific project and get more insights into what's driving the emission. In this regard, the unit is kilo CO2 equivalents per square meter per year, which is the unit used in Denmark. If we want to see it in a per square meter, then we can change the unit and have that perspective on it there. This allows you to go deep and see what's driving the emission and drive down into what kind of environmental data is used. And you also have a possibility to get a full overview of all of your building components, the emission quantity, unit rates, in a setup where you can also customize how you want to see this. Ultimately, you can generate a report either for, in this case, it's Denmark. If it was Iceland, it would be the Icelandic documentation. If it was Germany, etc., etc. But here we have both the documentation for the government, and we also have the documentation for DGNB, which has a specific verification process for building LCA tools. Now, these are my projects inside of Real-Time LCA. And many of you, probably like me, spend a lot of time in different agents. My agent of choice is Claude. So this is where I typically do my work. And within Claude, you have this ability to add connectors. Real-Time LCA has built an MCP server, which allows your chat agent, to integrate directly with your Real-Time LCA projects. Let's try to see how that works. So I'm creating a new chat here. It's Tuesday, and it's a happy one. Let's just start by looking at the projects I have in Real-Time LCA. So list my projects in RTLCA. Now it goes into Real-Time LCA. I've of course connected it with my specific user. You will always see our small logo here when it's going there. It has identified 7 projects in Real-Time LCA, which are the 7 projects we had before. And it's also making some observations on that already. Now, I really want to dive into option 5. So I will, deep dive into option 5. It's always a little nerve-wracking when you're doing live demos, but I think this will work fine. Deep dive into option 5 and give me specific reduction strategies for reducing emissions. Now it will go into the project using the Claude intelligence to give you answers. And it's always important to note, in any case, when you're using AI agents, you do need to qualify the responses in some cases, like anything else. In addition, connect Real-Time MCP server also to your own large language model, which you're using within your specific company, or maybe an open source LLM that you're using. So now it's fetched everything it needs. It's building the deep dive, and now it's also looking for low carbon alternatives for slabs specifically, since that's the single biggest item. It does use a little bit of thinking, so it's not the immediate responses that you get from ChatGPT, for example, but it's also doing deep analytical work in this case. Now, in 1 second, we will be seeing it creating the maps and the visualizations that you've asked. Again, from Claude, you can actually create your own report in PowerPoint or PDF or HTML or whatever your preference is. But now we principally have deep dived into option 5. We see that concrete cement is definitely what's driving it the most. Our threshold, so the limit that is in this project, and this is why they're doing LCA calculations at the earliest of stages. So we are in zoning phase. But since there's a threshold, developers, real estate owners, everyone that builds need to understand very early on what is the climate impact of this building. And this is why I mentioned earlier that in 2030, where emission threshold will be mandatory across Europe, we will see a dramatic shift in conducting whole building LCA from the earliest of the style stage and throughout the process, like we saw Frederick has done together with the student. But now we have different dashboards. It's looking at the situation. Concrete dominates. I'm not gonna read everything up. I just wanted to showcase how you can now talk to your whole building LCA through the agent that you're using. And in this case, we have a tier 1, which is what has the biggest impact. Replace generic concrete with low carbon product. Push the foundation thinner or switch to strip foundations. Boost rebar intensity via post-tensioning. And that's just material for material realization. But looking into design level, then they're also giving you concrete examples on how you can make design level changes that would reduce your emissions of this building. There's also biogenic and circular. In principle, yeah, ChatGPT can go into your uh, your uh, your whole building LCA and give it an analysis that you would spend hours or days discussing with colleagues, etc. So now you can zoom in and have that dialogue. I think it's super fascinating and very interesting how you can now talk to your whole building LCA, leveraging all of the intelligence that AIs like Claude is putting before us. Of course, we don't necessarily want you to rely on a Claude or a ChatGPT. So we are also embedding a chat agent inside of real-time LCA itself. In this example here, you're inside the material mapping view of a project, and we're asking it to summarize the total emissions for this project broken down by life cycle stages. So it's going into the project and it's sharing this information. Now, in addition, we're asking it to list all materials that we have not mapped over in the building component inventory. And this is how we work with all building LCA. We have a building component inventory where you have all of your building components, preferably integrated directly with your BIM design tool, but you can also upload an Excel sheet or an IFC file, etc. But here you're just seeing an example of how the agent is working inside of the platform itself. This has not been released yet, but will be released over the coming weeks, where we embed the agent also. But we find the possibility to integrate the platform with your agents of choice and also other places where you might need this sustainability data. It could be in Power BI reporting dashboards or whatever scenario you could imagine. The importance for us is that you have wide access to your data and you can talk to it and work with it across. In addition, I can also I can ask Claude to change the uh, cement to the recommended EPD, and it will go into real-time LCA and do the changes from Claude directly into real-time LCA. So you can actually work and improve your LCA calculation directly from Claude instead of actually going into the real-time LCA application. Here, Claude is luckily asking me to clarify some points before it actually does any action. And since this is actually real client projects, I won't ask it to do it specifically, but I just wanted to give you a demonstration of how it can work fully integrated with an agent. Yeah, I think that was the AI demo that I promised you in the beginning. I hope you found it insightful. I hope you found the full presentation insightful. Uh, and we will be glad to answer any questions that you might have. I see that Ahmad Al-Shibabi, who has asked, how can I get a PDF file? It is possible to download a report that you can convert to PDF. And we are, in the coming weeks, also adding a possibility to download a PDF file specifically. We have also an anonymous attendee who asked me, how did you link up your AI with the real-time LCA? Well, if you go to our webpage later today, you will find a instructional video on how to do that. But it's very simple. Under Claude, you can add connectors, and there we have URL code that connects you to the real-time LCA MCP server. And Lasse Andersen, he's a recent graduate, and he is just writing some praise to us. Thank you very much, Lasse. We are trying to be a future-minded tool, and the way we try to through future protect ourselves is being data-oriented. Because ultimately, everything that happens in a whole building is a data point. From the building components being imported in Excel or Revit or what it might be, to the actual calculations being done and the environmental data from EPDs. So we've always focused a lot on being a data-bound platform. And with AI, we're truly trying to push the boundaries of how we can make it more accurate and more efficient for you to work with the whole building else. Yeah, love to get some more questions from the audience. Maybe it was quite clear how Frederick, Ramboll, and Region Syddanmark succeeded in implementing a digital chain and reducing the emissions. We'll give you a minute to think about if there are more you would like to ask. If not, then I think we're going to end up with a gift of 10 minutes almost that we hope you will spend on exploring Ramboll and the engineering services and sustainability service that they provide. I'm sure that Frederick would be glad to share more on this insight and also how they could help on your projects if needed. And also feel free to go to our homepage at realtimelca.com, where you can request a free trial and try out the platform yourself. make sure to try out the integration with your agent of choice to see how that amplifies your capabilities, understanding, reducing, and documenting the climate impact of buildings, because it is so much needed. I thank you for your time. I thank Frederick for his time particularly, and I wish you all a very good day out there across Europe. Thank you for joining in the numbers and across all of Europe. This means that whole building LCA is truly taking form and shape, not only in the Nordics, where we have hard regulation, but also across Europe, where we're seeing growing regulation. Thank you very much, and we will end the recording and the webinar.